All right, this is an important concept, but can be a difficult one, especially as you're first learning it. A couple things to be aware of. Uh, the state is important. So here we have aqueous. That means it's AQ. That means it's in water. So that's telling us that something is in water. There's solids. There's gases that you might see. The other thing is to pay attention to how it's written. So here it says potassium nitrate and solid silver bromide are formed. So that means they are the products, even though they're written first. So you might start with those. Once you read it, you realize, oh, those are formed, and the reactants were the potassium bromide and the silver nitrate. Now this is a double replacement type that's happening in water with two ionic solutions. Notice there's no prefixes on any of these. Sometimes it tells you what it is, sometimes it doesn't. What we can see some takeaways from this, right? If we open our periodic table, we can see here that potassium is a +1, which means nitrate is a -1 because they must be charge balanced. So we got a -1 here, we have a plus for silver. So it's given us a lot of important information that we can use throughout writing this. So we have to do a few things. We got to remember to write the states. We got to remember to keep polyatomics together. So these are ionic bonded, but they have a polyatomic nitrate NO3 that must stay together. We have to use parentheses if there was a group of them, although it shows us that nitrates and there's no groups, so no parentheses necessary. And then bromide from our periodic table is a -1, and so we're going to bond that with both the potassium and the silver, which are +1. So no charge balancing. Everything's a 1-to-1 in this equation, which is great. If you have one with a covalent bond, you will see prefixes, so di or tri. And you also might see some gases like hydrogen, nitrogen, fluorine gas. Those come as diatomics. So you can't forget that gases like H2, fluorine, F2, oxygen, nitrogen, chlorine, those all come as diatomics in nature. So the equation's only going to say oxygen, but that's O2. Now, oxygen doesn't have to go in pairs if it's bonded to something else, like H2O. There's 2 hydrogens, 1 oxygen. But if it's an oxygen element, then it's going to come as a compound, O2. Okay, so let's write this one out. So first thing I'm going to do is aqueous potassium bromide. So I'm going to start with the K, Br, it's a 1-to-1. I'm going to put my parentheses and say aqueous, then plus aqueous silver nitrate, so AgNO3. Don't forget the aqueous. So these are both in solution. Now it forms aqueous plus a solid silver bromide. There we go. So this is actually interesting. We got a bunch of ions. Remember, if they're aqueous, that means the ions are floating around. They could conduct electricity. We got a bunch of them floating together. And then when they find each other, the silver and the bromines the attraction of those is stronger than what the water can break up. And so you actually are going to form a solid at the bottom of your beaker. The KNO3, those ions are just going to keep floating around. So they're aqueous unless you were to evaporate all the water off. So there is our written equation. Things to keep track of are those polyatomics, ionic solutions, looking for prefixes, diatomics, and then balancing. This one is balanced, and so we don't have to put any numbers in front. but that's a good thing to check for. There we go.